Hi everyone, today's lesson is for geometry, chapter 4. We are on lesson 2.2.3 for CPM geometry, areas of parallelograms, and trapezoids. So let's get started. One of the things today that I want to mention is that right after class today, we actually have a quiz. So stick around and hopefully look forward to that. So our learning targets today are to talk about conditional statements, as well as students are going to use rectangles and triangles to develop algorithms to find areas of new shapes, and these include parallelograms and trapezoids. So just a warm-up, identify the types of angles in each diagram, determine if the angles are equal or supplementary. So in the first problem right here, these two angles right here are going to be congruent. We call those corresponding angles. They're both on the same side and both on top of an angle or a parallel line. Number two, part B, these angles are congruent. They are alternate interior angles, meaning they're inside the parallel line, so they're interior, alternate interior. These two angles here also congruent. We call these vertical angles. Now these two angles right here are definitely not congruent, which means that they are supplementary because they are either congruent or supplementary. Those are your options. If, just a note, you could, let's say, put a value to this, like let's say that's 80 degrees, that's 80, and so therefore that's 80. So you can see, like, these are vertical angles, those are alternate interior, and therefore this angle and this angle would be supplementary, which would add up to be 180 degrees. So this angle here, also this angle here, and this angle also supplementary as well, right? Part C, this angle out here and this angle out here, we call those alternate exterior angles. They are congruent. And these two angles on inside right here are not on the same side inside like these are. These are same side interior angles, and those angles are also, those are supplementary for sure. But these angles, yes, are supplementary, but just note that they're not same side interior angles. So like if I'm asking you a question on the test and says, which of my angles are same side interior angles, these would not be an example of that. This would right here, but they're both supplementary, not equal, unless they were perpendicular, right? So just to go back really quick, if I have two parallel lines cut by a transversal, and if this angle inside here or inside here was like this here, 90 degrees, right? They would be congruent, but they're still supplementary. Yeah, the only time that they would be congruent is if they're perpendicular lines. That's it. For this one right here, I'm asking you to find the area of this shape. And I do know it depends on how you want to break this up. I'm just going to break this up like this little angle, this little box right here. So I'm going to take the big area of the big rectangle plus the little box. That's my objective. The area of the big box is going to be, or the big rectangle is going to be 11 times 3. So that's 33. So this one is 33. And that cuts across. Now, if this is 3 right here, that makes this 2, because 3 plus 2 is 5. If this is 11 and this is 8, that makes this little leftover side 3. So the area of the smaller box is 6, so that's 6. Now remember, these look like these are feet, and so what that's telling you is this is 11 times 3, so 11 feet times 3 feet is 33 feet, let me write it out, feet squared, plus 2 feet times 3 feet, which is 6 feet squared. So that makes 33 plus 6 is 39 feet squared. Now for this problem right here on the right, we would take the larger rectangle and subtract the little hole in the middle. So the larger rectangle is going to be 12 meters times 24 meters. I'm going to use my calculator. I've got 12 times 24, and that is 288. So we know this is 288 meters squared plus, or excuse me, minus, because we're taking away that little hole in the middle. And so we've got this rectangle, which is 4 meters times 8 meters, which is 32 meters squared. So we're going to go 288 minus 32, which makes 256 meters squared. For this problem, these two problems also find the area. This is just base times height. Sides are perpendicular, so I would just say 2x plus 3 times x plus 4. And there's no values, like I didn't give you the total area, so you just leave it like that. But we would multiply and use the FOIL method. So 2x times x, remember, keep the base, add the exponents. So that's 2x squared. 2x times 4 is plus 8x. 3 times x is plus 3x, and 3 times 4 is plus 12. So we have 2x squared plus 8, 9, 10, 11x plus 12. And so this would be just the area because I didn't give you like a value. Now for this problem here, I mean, half one, this one I just have to decide, do I want to find the area of the whole large rectangle, which is 27 minus 18, and then basically subtract the little parts that I have here. So, I mean, that's an option to do, or you can break them up into little pieces, knowing that each of these is congruent. So, meaning if I knew, because see, these little pieces here are the same value, and so are the other ones. So I could break this up into 3 little sections. That might even be easier, and just add those up. So, for example, the first one, this rectangle right here, well, if this is 18 all the way going up, and I know this is divided into 3 equal parts because of the congruent little signs there, then 18 divided by 3 is 6. So all of these 3 sides are 6. Likewise, if this is 27 and this is broken up into 3 parts, right, 27 divided by 3 is 9. And so each one of these parts would be, an additional 9. So like this right here would be 9. Then this part here would be 18. And then this part right here would be 27, like we have here. So I'm just going to do that. So the first one is 27 centimeters times 6. So 27 times 6 gives me 162. So I have 162 centimeters squared plus, now I'm going to look at the middle one, which is 18 times 6, and that's going to give me 108. So plus 108 centimeters squared plus 6 times 9, right? And that's 54. I'm going to add all 3 of those up. 54 plus 108 plus 162 is 324 centimeters squared. And that's the area of that unique shape. Now, just keep in mind that when you are working these problems out, area is always squared. Whether it's, you could say this is all unit squared. You could put a big parenthesis around that and say, well, that's unit squared. Centimeters squared. Perimeter is centimeters. That's like adding centimeter plus centimeter, which is just centimeters. But when you're multiplying them, that's definitely always, area is always squared. So find the area. We've got, we know that this is a actually, this is not a rectangle. This is a triangle. So your options are either to find the area of the rectangle, which is 5 yards times 14 yards, and then take that value and divide it by 2, which is the same thing as saying, well, this is a triangle, and the area of a triangle is equal to 1/2 base times height. But remember, always remember that the base must be perpendicular to the height when you're finding the area of a triangle. So for this first problem, I'm just going to go 1/2 the base times the height. So 1/2 my base is 1/2 of 14 is 7. So we have 7 yards times 5 yards, and that makes 35 yards squared. So the area of this value is 35 yards squared. And let's see, 21 millimeters squared. So now these ones right here, this is a triangle. And this one right here is just a shape where we're going to actually have to add up little parts to it. and it looks like these bases are exactly this, or these are the same. So like if I wanted to break this up, I would say find the area of this shape right here, which is this middle part, plus 2 areas of triangles. So that's what I'm looking at to do. Now, the area of the triangles, that's pretty simple because that's my base and my height are already perpendicular. So this is going to be 2 times 1/2 my base, which is 8, times my height, which is also 8. So 2's are going to cancel. So the area of this shape here plus this shape here, right? So it's 2 times 1/2 base times height. That's 64. We're just going to call it unit squared. Now for this shape, however, a little bit trickier because I don't have an actual height. And can I assume that it's a square? I can't, because first of all, I don't see 4 right angles. I don't see any kind of anything showing me that it's a square, no indication of that. So what that means is I'm going to use Pythagorean Theorem to find this hypotenuse's length. So that's going to be 8 squared plus leg squared equals my hypotenuse squared. So 8 squared plus 8 squared is equal to the hypotenuse squared. 64 plus 64 is 128 equals h squared. Now, the way you would reduce that, I mean, realistically, you know that 128, well, we want to, first of all, we want to find the root. So take the square root of both sides in doing that like this. And then I just have h is equal to the square root of 128. So when I'm doing that, I can break that down. And so 128 is actually the square root of 64 times 2. That's what it is. And so what's happening here is the square root of 64 is 8, and then I've got root 2, which means this is my actual height, 8 root 2. And so in order to find the area, because remember, we found the side, we got to find the area, which is base times height. We're going to add this 10 times 8 root 2. So 10 times 8 root 2. So keep in mind, numbers get multiplied with numbers. So 10 times 8, so that's 80 root 2 plus 64. And both of these, even though I can't combine the root and the number, I can just put a little u squared outside saying, hey, that's my answer, but unit squared. And of course, I could also just write it like this, 8 root 2 unit squared plus 64 unit squared. So I could split it up like that as well. For this problem here, I want to find the area. And in order to find the area for this, I recognize that it is a equilateral triangle. That being said, that means all my sides are 10. So when I'm trying to find the area of a triangle, I already know it's 1/2 base times height, but my base has to be perpendicular to my height. So this is my base, and this is my height. Okay, so now, a little bit tricky here because I don't have the height. So, and if this is symmetric, see how it's like isosceles triangles and equilateral triangles will do this. This splits this up into 2 equal parts, so this is 5. So I also can use Pythagorean Theorem to find this extra side here. So I'm going to say side squared plus side squared equals my hypotenuse squared. So I'm going to say 5 squared plus x squared is equal to 10 squared. So that means x squared is equal to 100 minus 25, which makes 75. And then when I go x equals the square root of 75, I can break that down into root 25 times 3, right? And those are still roots. Square root of 25 is 5. So this is actually 5 root 3, which means that my height, this value right here, is 5 root 3. So when I use my formula to find the area of the triangle, remember it's 1/2 my base, which is 10, and that not 5, but 10, because it's the whole base, right, times the height, and that's going to be 5 root 3. And then 2 is going to divide into the 10 5 times. Numbers get multiplied with numbers, and so the area of this triangle is going to be 25 root 3, and I don't see any units, so we'll just call this units squared. And so that's the area of that triangle there on the right. Now, again, we did talk about area of trapezoids and area of parallelograms, and just a note, what they're telling you in this actual slide is that not only can we use our formula, which we've already talked about in a previous day, but the formula being height divided by 2 times the sum of the bases, which is going to give me the area of the trapezoid. Area of a trap. I like to draw the little pictures there anyway. But note that you could also find the sum of the parts, meaning I could split this up into little parts. So that's that right there would be like a rectangle or a square, depending on whether or not, you know, the size of the trapezoid. And then I would have a triangle on the left, and then I'd have a triangle on the right. So realistically, I could use each of these, right, to find the area. And just note that if I have two triangles, right, that's a half times base, a half base times height, and a half base times height, and then this is base times height. So like I'd be adding all three of those parts together. Likewise with a parallelogram, or by the way, you could just use the formula as well. And the area of a parallelogram is our base times our height, right? And so the base times the height. But again, like a triangle, when I'm trying to find the area of a parallelogram, what's most important is that you recognize that, yes, it's base times height to find the area. However, the base must be perpendicular to the height. Absolutely. And, you know, if I wanted to find the parts, I could do that, and I could break this up again like that into this shape. So I'd have this shape plus this one over here, and then plus this one over here. So again, you've got a half base times height, a half base times height, right, is a whole base times height, and then you've got plus that middle part, which is that square, or pending the shape. So in order to find the area of this trapezoid, I'm going to use the formula, which the area of the trapezoid formula is equal to height divided by 2 times the sum of the bases. Now, I do know that a lot of people actually like to do this and say 1/2 base plus base, right? Add the bases up, and then times the height afterwards. So like they multiply that height out. Either way is fine. You just have to figure out what works best for you. I just like the formula that is just all, and just use it at once. My height, now remember, the height is always perpendicular to the base. So if this is my base, right, then this must be the height. So we're going to go 3 divided by 2. That's the height divided by 2 times the sum of the bases. So that's 5 plus 8. Base plus the whole base. Now be careful too, because sometimes they'll just give you like a part of the base. So you got to make sure you're asking for the whole part. And so 8 plus 5 is 13 times 3, and then divide by 2. So that's what, 39 divided by 2, and this is inches, so that my answer would be inches squared, and so that would be my area. And, you know, approximately, you could just say, you know, the area of a trapezoid, just rewrite it, the area of the trapezoid, you could rewrite it as just saying it's about 19, and it is 19.5 inches squared. So you could rewrite it like this, or you could just put it as a decimal. More area problems here. Area of this triangle would be 1/2 base times height again. So 1/2 my base times my height. And I think the main thing here is 8 times 9 is 72. This would be centimeters squared. I think the main concept for sure is that you need to make sure that you, when you're finding the area, that anytime it's a, you know, finding the area, whether it's a parallelogram, a trapezoid, a triangle, or a square, the base always has to be perpendicular to the height. Here, 11 times 11, 121 yards squared. Base times height. Base would be 26. My height would be 14. So this would be 26 times 14. 26 times 14 is 364. So this area would be 364 meters squared. Now, be careful. You notice that I didn't use the 18 because a lot of times they will give me added information that I actually don't need. So let me put the answer up here again, 364 meters squared. But what I want you to recognize is if I was going to use 18, then I would have had to show some part where that height was perpendicular to that. You see that? If not, then there's no way I can use 18. 18 is just an extra piece of information that they gave me that I don't need. Similarly, like 11, I don't need 11. I need to use height divided by 2 times the sum of my bases for this trapezoid. So I would go height, which is 8. So I'm going to go 8 divided by 2 times the sum of the bases, which is 6 plus 21. So that's 4 times 21 plus 6, which is 27. And 27 times 4 is going to give me 108. I think that's right, 108. Yeah, 108. And this is inches, so this would be inches squared. Area of a parallelograms, again, base times height. So this would be my base, this would be my height. So we've got the area of this. This is a parallelogram, is going to be height, base times height. So we're going to say 15 inches times 8 inches, and 15 times 8, 120 inches squared. And for this one, I have a little bit of extra information for sure here. Which one do I need? Do I multiply 5 times 4 or do I multiply 4 times 7? So remember, added information, the base has to be perpendicular to the height. So the area of this parallelogram is going to equal base times height, which is 4 times 7, and that's 28 units squared. If there's no units, I'm just going to use u squared. So we're done. Thanks so much for watching. You have homework, which is 2.2.3, and we're getting ready to take our quiz. So good luck to you on your quiz, and thanks for watching.